Did I lose my, are they going to turn that on? It was up there.
Oh, it was up there?
Yeah, I don't know what happened.
Maybe it took it out. Showing up as the, oh yeah, that data.
That's good. I could see myself. You guys give me when you're ready.
Yeah. Are we good? All right, we're starting now. I'm pleased to introduce Michael from MarkLogic Corp. Michael is a principal technologist with MarkLogic, the world's best is for integrating data from silos, and the only NoSQL solution built for the enterprise. He spent many years in client-facing roles, helping to match technology to business value. He loves the beach. All right.
I do. You can
And
see.
social media. All right. He'll be presenting a talk titled Agile Integration Using an Enterprise Data Hub. Please join me in welcoming Michael.
Hey. Well, thank you, everyone. Thanks for coming. So you can see that's me at the beach over there. Today I'm going to talk about basically a pattern. Okay, I work for MarkLogic. We sell an enterprise data hub, but this is a solution that you might be able to build yourself. Obviously, we'd like you to come to us. But I'm really here not to talk about MarkLogic, but again, talk about integrating data from these various data sources. People call them silos, bringing them in to a place where you can get 360 actionable views. Okay, so that's the essence of what we're going to talk about. And we could keep it informal. I know there's QA at the end, but if anybody has a burning question that they want to shout out, feel free to do that. I don't have a problem with that. So a little bit of fun here. We all know this is true. The world is changing. That's me with my first car way back when. This is my son. He's got that one. You know, he's out in space. My first airplane, and my daughter's there playing with the Falcon Heavy. Okay, so. But we know the world's changing. We know people certainly change. That's going to be me in a couple of years. So, all right, so enough of the fun stuff. This is a big data conference. We all know that data's changing. Okay, you have new source data. You have requirements that change. You have new customer requirements. You have competitors if you're in the business of competing in your company. All right. The idea here is that where the data comes from, how it's accessed, and then who accesses the data, it's changing constantly. And I'm a technical person. I'm in technical sales. My title's principal technologist, but I talk to a lot of individual application developers, IT people. The most sought after feature that they're looking for across industries is flexibility and agility. The ability to react to all this change, whether it's in your data, in your requirements, in your business situation, in the technology. So that's what this pattern is all about, being able to handle that change and pushing the data level changes down into the database. Okay, so that's what we're going to review here. Now, there's been a lot of buzzwords over the year, particularly when you're selling. You hear things like thinking out of the box and the paradigm shift. Some of them are really good. This one, 360, I think, is a really good one as well, because it captures what many organizations across industry are trying to do. So you have multiple systems of record in your enterprise. In a manufacturing company, you might have an enterprise resource system, right? You might have a CRM system. You have an HR system for employees. You have financial and accounting. These systems are going to be there for a long time. They do excellent jobs. They perform valuable functions. But when you want to develop, say, high-value business application or other high-value business applications, it involves taking information from each of those systems. So think about customers, right? You have information about your customers in your sales system, your marketing system, your support system. I work a lot with the media and entertainment in LA, folks like Disney and Warner Brothers. They want to get in touch with their consumers, and they have various touch points for those consumers, right? They have people downloading their movies, doing video on demand. Disney, in their case, they have a lot of people visiting their parks and their attractions. They have a port or retail outlets. So they want to make sure they're out to do direct to consumer. You might have heard that if you deal with customers. And they need to know what their customers are doing. And they want to do mass customization. They can take demographic information and say, okay, males 18 to 25-year-olds like this type of movie. Okay? But that's what they want to do, is find each individual male and say, okay, you liked this movie, what am I going to recommend for the next movie? And it might not be the same across all 18 to 25-year-old males or females. So the idea is to collect this information, get a 360 view of a customer or a product or a supplier, and do something actionable with it, do something high value. So just going through a few more of these, you have product 360 initiatives going on in customers. And again, look at this. If this information is going to come from CRM systems, ERP systems, you want to build dashboards. So you want to do reporting and analytics, and you also want to run your operations. So we call that observing the business and running the business. And with this design pattern, you're going to be able to do that. Same thing in healthcare. I'll do these quickly. A patient has information in various different systems. Suppliers, if you're in manufacturing, you've got to know how they're performing, what the contracts are. And then this finally, HR. Everybody has employees if you're in a good-sized organization. You have onboarding type databases, you have training, you have employee recognition, and just different information about something you call an employee that you want to get a 360 view. Okay? So what do these organizations want? Well, that's just what I've been talking about, 360 view. So if you're at a business level, if you're in a business function, this is the kind of mission statement that you might want for your program. Give me a 360 view of my customers or my employees, right? From a technology standpoint, many of you are technologists, you might be architects or DBAs or business data analysts. You want innovation. There's a lot going on in business analytics, machine learning, AI. If you're developing these applications, you want agility. You want flexibility. You want to respond to all the changes that we talked about in the beginning. And if you're a manager, you want to be cost conscious, obviously. And reducing complexity is always good, because that adds to technical debt. It increases your costs. And it makes it difficult to respond to the next change that's going to come your way. I think we're doing a little bit more fooling around here. That's a little bit of animation. So how do enterprises deal with constant change? Well, by being agile. These are my colleagues. They're very agile. I think some of them work for Cirque du Soleil or something like that. I got a couple of more here. Let's see. Entertainment. You guys know who that is? Elastigirl. She's very, very flexible. This guy, I just saw him on the net. And I cannot give a presentation without making reference to The Princess Bride, because that's my favorite movie. For any of you guys out there. Okay, so I'll just throw the characters up there. But being innovative, that's something that's a goal of many technologists and business people. Okay, so enough of that fooling around there. I just had to throw that out. So what are some of these agility and flexibility killers? Well, I don't want to beat up too much on relational databases, because they do excellent jobs in the systems in which they're deployed. Could be financial systems, online transaction processing, even data warehouses. But one of the key attributes of a relational databases is that you've got to set up a schema in advance. Sometimes that effort can take weeks, it could take months. I've even heard of it going well over a year. And when you want to do things, when you want to move from running your business, over here on the left, this OLTP, transaction processing, to observing the business, you've got to extract the data, transform it, and load it into something like a data warehouse or a data mart. Okay? That takes time, and it really slows down flexibility. And if you talk to us offline, we have examples of customers that we've served that tried the relational technology for this business data that was, say, not in relational form, more semi-structured or unstructured type data They wanted to get actionable information from it, and relational technology just didn't fit for them. So they came a NoSQL solution, which we'll talk about. So focusing in more on the problem, this is sort of the cycle that you have to go through. You have to understand your data, design a data model, possibly do some ETL. Then you, depending on what your queries are, you're going to create indexes, and then you'll build your application. This, as I said, can take months, if not longer. And what happens? All these changes come into play. You might have people leave the organization, right? The requirements from the stakeholders change. Because any of you that have developed applications, you sit down with the stakeholders and say, we want this, this, and that, but all of a sudden they see a prototype and they say, no, we really want this. So there's that MVP type mentality, develop a minimal viable product, get agile, show them something first, get feedback, and then move on, right? Well, this is the type of environment that we're all in today. So problem here, and you have to restart this whole process again. So what many companies are doing today is they're moving to this new approach. It's calling it an operational and transactional enterprise NoSQL database. Now, you may have, there are many others out there beside my company. If you ever come and talk to us, we'll show you why we're good. But the idea here is to be able to bring the information in as quickly as possible. So no matter what NoSQL database you're using, that's pretty much an attribute of that technology, just getting the information in, getting access quickly. So you don't have to build a schema, a relational schema. Typically, when the information in the database is it gets indexed on the fly, and you're able to access it via search. With relational technology, the common access method is SQL. That's a good method to access it. But nowadays, people want to do Google-like search on their corporate data. The other thing that you want to have and you don't want to give up, and that's why we use the term enterprise, are these features like security and ACID transactions. You guys know what ACID transactions are? It's essentially, you know, okay. The best example or a good example I can give is when you debit your savings account and transfer it over to checking, you want both those transactions to happen, both those events to happen either all or roll back, right? You don't want to debit savings and not have it show up in checking due to a failure. So a transactional system will say, okay, both didn't happen, so roll it all back. That's called ACID. It's ACID transaction. Make either all or nothing. And the isolation is the I, and durability. So that's a common feature in any enterprise database. And you see it in all the popular relational systems. They had it for a while, Oracle, MS SQL Server. But we have it well, if you're looking for a NoSQL database, it's an attribute that you should require if you have a mission-critical application. You can't lose data. Okay? So this is a high-level view of this pattern that we're talking about. Information can come in from relational systems. They might be the systems of record. You might get it from mainframes. We just did a mainframe migration at Sony. It could be in the file system. It could be in social media, Twitter, Facebook, or some other data sources. But you want the ability to bring it in and do flexible modeling incrementally, and then develop that and then use that model for different applications. And then maybe you might be mastering data. Say each of these systems has a different view of customer. You'll bring it in, master it in this NoSQL database, and then push it back out to the systems of record, so to sort of start standardizing across your organization. And then downstream of this pattern that we're going to talk about is where you run your business and you observe your business. So you could have transactional applications. You could do analytical system, analytics like business intelligence. Or you could just serve up data as RESTful endpoints. So somebody hits your data with an HTTP request and you send it on out to them. And this whole process of using this pattern, it's a four-step process that's much more quicker, much more agile. You load the information, and as I mentioned, it's indexed on the fly, so you can search it immediately. That's the discover, and you validate. Now, in step 3, this is where we do sort of that ETL, but not on a grand scale. It's done incrementally for the task at hand. So like I said, if you have product information or customer information that comes from separate systems, you might standardize on things like, well, how are we spelling first name and last name? Do we have F name or first underscore name? And then the values themselves, right? What values are we allowing in certain fields? That's sort of a data quality issue, a master data management issue, and a harmonization issue. Also in that stage, you might do some kind of data enrichment. So address information might come in, and you might send it out to an enrichment service to get the geo-coordinates. And why would you do that? Well, because many applications, whether they're web-based or mobile, are using map-based type of features. So that's very popular. You might do natural language processing. So in a database like this, you can take in files that are full text. Somebody might have written a report and just spewed out, did a brain dump and spewed out a whole bunch of text. So you could go to a natural language processor or an entity extractor and identify the people, the places, the things, and put tags around them. And now you've got some structure, something that you could search, and it makes it much more actionable. So that's step 3. And then step 4 is the deliver, and that's either going to a web app, a mobile app, or like I said, just data for somebody to consume. When you build this type of application, these are the requirements. Deploying to any environment. So that means sometimes you might deploy in your behind your firewall. So some companies still have their own data centers. A lot of companies have outsourced that. Still other companies, and most companies are going to the cloud. So you have to be able to deploy in any environment. Transactional consistency, that's what we talked about, the banking example. Scale, elastic scalability. We deployed an application with the Saturday Night Live. You know those guys on every Saturday night. They've been around for 40 years. They have a mobile app where you can access all 6,000 of their skits online. Well, when they released it, they did it in Amazon, and people started hitting the app. Our servers were behind it. We had to scale up elastically to handle the load, and then a couple of days later scale back down. So a lot of applications are like that. They see a surge in consumption of the application monthly, quarterly, weekend, something like that. People don't want to have to buy for the extreme case. They want to go up and down here. So these are the requirements, and these are the features that you need in this pattern. You need the ACID transactions, the scalability, high availability, and the security. So going down deeper into the 4 steps, loading data as is, the data that you're looking at, typically that we see on the left are either JSON, XML. Semantic data is a graph type of data. I mentioned geospatial data. And then binary data also can be brought into an enterprise NoSQL database. And what we would do is store pointers to that binary data. Those can be images, those could be PDF files. And actually PDF files can be processed as well to extract the text and make that searchable. Okay? There's various tools to bring the information in. Have you guys heard of Apache NiFi? Apache is an open source project. Yeah, so we're actually taking that product and we're going to productize it and keep it open source. Obviously, we'll contribute to that community. But there are a lot of connectors springing up from that community to bring information in from the various sources. So you get it into a system. So that's loading the information. Very easy to get information into a NoSQL database. The model, are you guys familiar with document models in NoSQL databases, or mostly relational technology? Both, yeah. So yeah, in NoSQL you've got 4 general classes. You've got key value, document, wide column, and graph. This is what a document model like. This is a simple JSON file. You could see XML file. And this is a more natural way of expressing business data. Obviously, it's text readable. It can support hierarchical type arrangement. And it's an easier impedance match with your application. What I mean there is if you have, say, a purchase order in your application from a form, in the past, you would put it through an object relational mapper and then store, say, a purchase order in 3 different tables: the customer, the order, and the item table. Well, with this kind of pattern, you just put the document in, the purchase order document, and it makes it easier to get it out when you want when you want to view it or operate or approve it or something else. You don't have to split it up. You don't have to do that shredding and joining. So companies have found this a much more flexible way of developing code. So if something changes, this actually has its own schema. This is a schema within the document, okay? And if you want to add a field, you can add something. Or if you want to change it, it's not like you have to go to the DBA and have them add a column or add a table. It's much more easier to adapt this model. Discovering and validating, this is about bringing information in and indexing it on the fly. So a good NoSQL database will index every word, probably a couple word phrases, even the structure it will be indexed, so that once it hits the database, you can search on it automatically. And then those are typically out-of-the-box type indexes. A good database will also allow you to create your own indexes, say on date ranges or numerical fields, so that you could do analytics on top of that. Okay. This talks about how and this is a kind of a document. It's a tree structure. This is what it looks like in XML form. But when it breaks out, this is SAR. We do a lot of work with the government. This is called a suspicious activity report. So this might come from the FBI or a police agency, right? Somebody saw a blue van. Well, that's unstructured text. And you want to search on that. Hey, we heard something about a blue van. Reports in our database. You want to be able to search on that, right? This is a date. Now this has values, and somebody would say, well, I want to see blue vans, but I want to see them between these different dates to see, to catch my bad guy here, right? This is a location, so this is latitude and longitude information. So you might be doing this type of search on a map-based, right? And this is that graph-based. This is called a semantic triple. Basically, it's a subject, a predicate, and object. And this says license plate has a value of ABC123. And then you could hook those in a graph. And you could say this license plate also belongs to this state of California. And you could see how information about this license plate over here can branch out into, say, the value on the license plate or the state or maybe who owns it. That's more of a graph-oriented type data structure. Okay? And then once you get the information in, then this modeling and harmonization. Now, this is a pattern. We call it the envelope pattern. These could be your different source systems, right? It could be your CRM system, an ERP system, an HR system that has customer information, if we're talking about customer or product. What you want to do is maintain the original source information in your file so you can maintain the provenance. Where did that information come from? Also the lineage. As this information changes in your database, you want to know who changed it, what was changed, when it was changed, right? But if the harmonization comes, okay, I'm going to take, say, the first name and last name and standardize on the format. And standardize on the values with reference data, say state information or gender. I'm going to standardize on F for female and M for male instead of female and male, or numbers that people use for male and female, right? So the point is the information here is what's going to run your application that is immediately important, the one you're requiring to solve now. Right? And it could evolve. If later on you want to bring up more information and canonicalize it, that's what we call it, canonicalization or standardization or mastering, you could do that. It's a very, very flexible type of arrangement. Okay? And again, if you want to look at the old data, that's searchable. That's available to you. Right? And so this is how... And here's another, this is, again, as this information is brought in, you could enrich it with things like geolocation information if you have addresses, entity extraction, or any other type of enrichment through various services that are available to you. Now I'll just go quickly through this. The other thing that this fosters is parallel development. So here you got 10 different teams, right? And they are just pushing through, getting their job done. Eventually they might merge their changes in the data. But the idea is Team 1 doesn't have to wait around for Team 10. They could develop their application. They don't have to wait till corporate develops this Uber schema. They could use the data immediately and do the job at hand. Okay? Semantics, as I mentioned, a good NoSQL database will be multi-model. Not only a doc, but they'll have this semantic model, and that's that graph that says a subject, a predicate, object. The customer bought this item. This item is part of this assembly. This assembly is provided by this supplier. So you can see a graph pattern emerging there. Okay, and the example here again is criminal. You know, when you're looking for a bad guy or a bad actor, you're investigating very diverse sources of information, right? You're looking at financial records, you're looking at where this person might be, any reports filed on that person. That type of information resides maybe not even in your purview. You might have to get that from partners or other departments, right? Well, the same kind of situation applies within organizations. I know corporations like to be integrated and all that, but typically there are these fiefdoms or these silos of information, and you might want to bring it together with a semantic model. Okay? Here's a very good example. When a customer places an order, and you know the order contains a product, a good semantic database can infer, this is inferencing, the database will say, that customer actually bought that product. Okay, now this fact doesn't exist in the database until you search for it, and the database will make the inference and create what's called a triple, and actually create this and say the customer bought this particular product. So that can be powerful in that it gets the database to do some of the thinking for you. It's a simple thing, but if you have to do it at scale across millions of records, it's where you want to leverage the power of the system. And this is the kind of view you might get for your customers. So you have, like, John was born in at this time, works for this company, is a father of Richard, etc. This is the kind of information that you have about people, about employees, about customers, about products, about suppliers. And I mentioned that Saturday Night Live thing. This is the application. It's a mobile app, but they tagged all their skits with who the actor was, well, that's the actor, the talent, what the character was, what the storyline was, so that if you were browsing this information, they can navigate you to the various characters and recommend skits that you might like. The whole idea was to keep you engaged in this application. And if they saw that you were swiping through the recommendations, they'd ask you a question, and they would tune the engine using the semantic technology. If you tweeted about this on Facebook or you looked for more information, they all use that information to enhance the engagement with you. So customers, companies that are looking for better engagement with their customers are doing things like this. And then when you deliver the data, you want to be able to deliver it in the various languages that your staff uses or your outsourcing organization. But JavaScript is very, very popular. You still want to support SQL. You want to be able to put up REST APIs. Java is used heavily. Node is server-side JavaScript or middle-tier JavaScript, actually. And then the type of applications you develop could be, again, running your business, transactional apps, analytical apps, or just serving up data to downstream systems. And this is just a graphic of a transactional app and an analytical app. So this is probably the most technical slide I have, but this is a graphic of this pattern that we call an operational data hub. Something you could build yourself probably from open source components, but if you want to talk to us, we have one. But this is meant to convey the idea that there's lots of data sources out there. This is a big data conference, and we talked about it. Relational databases, various silos. One of our customers was trying to integrate HR data from their mergers and acquisitions. They had 140 different data streams. Okay? And they had to bring that in to try and create a unified view of their employees. Okay, so they had to ingest all this information, and they went through this curation process. They wanted to do some validation, they had to index, but this harmonization process is where, you know, depending on the applications they wanted to build, they would take certain pieces of information and harmonize on the data fields and the data values. Okay, they use semantics, and then this part, once you have the information in this type of database, this data hub, you can create relational views from it. So if you're using a business analytics tool like Tableau or MicroStrategy, they typically like to see tabular-oriented data. You have the option of doing that from this pattern, okay? And then you could also just create semantic views, which is those graph patterns of customers or products or other types of graph patterns, right? And then again, it really a few types of downstream. So you're driving business processes. You might be running your business on transactional apps and doing analytics and reporting, or just delivering data to downstream. So, all right. So a good NoSQL database will have out-of-the-box APIs for document management and, say, searching. Also, you will have the ability to develop your own server-side modules and surface those as, say, REST endpoints. So the APIs would be published here as either, typically as a REST endpoint, is where a lot of companies are using today. Okay? And then very important down here, I mentioned that enterprise pattern. You want to have good data governance, particularly in mission-critical applications. So you want to be able to track provenance and lineage, but those aren't the only aspects of data governance. You have data quality, you have your data architecture, you have your mastering, and a few other things that you want to wrap into your overall governance strategy. And a good operational data hub will allow you to move those functions closer to the database as opposed to doing it in the application. If you do these kinds of things in your application, they're going to be one-offs, they're going to be brittle, they're going to get out of sync, and so that's why it's better to spend your developer time on doing whatever it is your company does best, whether it's retail or healthcare. Those are high-value business functions that you don't want to develop database technology. You don't want to develop transactionality, right, in your application. That stuff belongs in the database. So now we're back to fooling around here. I don't know. That's the end. Take this. That means go out and have fun. Maybe Princess Bride is a little bit of an outdated movie, huh? I should stop using it. Shrek? Shrek is a little modern. I know that's Billy Crystal there. I don't know. It's a fun movie anyway. And that's me again. Feel free to contact me if you have any questions. That's me on Twitter as well. How did I do with time? Was it good? Yeah, any questions? Got one out there? Yeah, so those are three, well, Cassandra and MongoDB are NoSQL databases. Cassandra is a wide column database. MongoDB is a database ours. We don't really consider them competitors because it's a different use case. As I mentioned, we're more of an enterprise type mission critical database. So you would find us in companies like JP Morgan Chase doing all of post-processing on trades. Cassandra you might find in applications that take a lot of stream data from network devices and more suited for a wide column, sparse database type application. MongoDB is good for applications where you don't need that transactional consistency. Even that, I know they're getting better with transaction reliability, but we're cautious. You have data that you can't lose, you may not want to look at that type of database. But it's good for okay, so Hbase, that's a wide column or big table type technology on top of Hadoop. So you know, it's good technology if it suits your if we actually work very well with Hadoop. We have a connector, so a typical case would be for large amounts of data to go into Hadoop, and they would process it with it used to be MapReduce, now it's like Spark, other newer technologies, and then bring a subset of that curated data into our system or an enterprise NoSQL system to do search and to run mission critical applications. So, with those. Any other questions?
On the scalability side and data sharding, like how does that work versus like compared to Cassandra versus this one?
Yeah.
Like how does it shard?
Yeah, so MongoDB does sharding. Our particular NoSQL database is just it's a process that runs on a virtual machine, and when you want more, say, query, or either more query capability or data capability, just add another virtual machine and it scales out horizontally. We have algorithms that balance the data automatically. Yeah. So and then you could do what we call tiered storage. If you have, based on policies, you might move certain data. If it hasn't been accessed a while, it could move all the way back to S3. Okay. Your more recently accessed data would stay, say, on SSD. So that's all policy driven. Yeah. Yes, sir.
Sorry, I didn't catch that. I think I kind of got it now. So MarkLogic, you have your own proprietary database.
Yeah. And an integrated search engine. A Data Hub is an open source tool that sits on top of that and allows you to ingest data, go through these harmonization steps, and then create, say, REST endpoints to drive it downstream. Yeah.
So somewhere you mentioned about MicroStrategy and Tableau, right?
Tableau, yeah.
Yeah, so I don't know too much about MarkLogic. Traditional Hadoop work. Transform that into more relational, into high.
Right.
So you feed it to Tableau or Click.
Right. MicroStrategy, yeah. Well, you're correct. A lot of these tools like Tableau, Click, they're looking for a relational view and they want to hit it once the information comes in. Because we index it heavily, we use something called TDE, template data extraction. So we can create a relational view from that information, and then it can be accessed through, say, an ODBC connection. So that's a very typical way to access real-time data and do real-time queries. What they're doing now is they're realizing that some of this information is just shouldn't be in relational form. So they'll actually submit a query and bring back a JSON file or an XML file and then use their visualization on that format. So yeah, there's sort of a shift going on. Because most data today is not relational. It's you hear various figures, but they say about 80% of information is unstructured or semi-structured. And you could imagine all the office documents out there, the business documents that just don't fit nicely into the rows and columns of a relational database. Yeah. Yes, sir.
Just kind of thinking back where you left off. So MarkLogic as a product, you talked about an open source component, you talked about a NoSQL component,
Right.
and then there's also this hub component. Can you maybe talk about that a little bit?
Yeah, so the product that's not open source is the integrated NoSQL database and the search engine. That's pretty much what the pedigree, that's what we sell either as a license or on Amazon as a service. Okay, but we contribute to the open source community with tools. So there's a tool out there called a Data Hub, and it's something that can be downloaded. It's on GitHub, and you could use it, and it helps you ingest information into MarkLogic, harmonize it, transform it, and basically run that pipeline that you saw. Set up endpoints for applications to consume. And the application could be a web application, mobile application, or just a BI tool. Yeah, so that's open source.
So is it kind of like a data virtualization of sorts then? You're building endpoints, you said?
Yes, once you have, so the data resides in our system in a compressed binary format, but it's typically JSON or XML or just straight text, along with all the indexes that we create. So the data size is going to grow the more and more indexes that you create, but it's going to give you more capability in what you do with the data. When you say virtualization, I mean these REST endpoints are just endpoints that you would hit with an HTTP request to either search on that data or upload data or delete data or run some business function. So the system itself can be programmed. If you work with Oracle, right, you have PL SQL, and some of these other database engines, they have programming languages that you could develop back-end data processing modules. And that's either for database data management or analytics, right? So you can develop a database service using JavaScript. So you would program in MarkLogic in server-side JavaScript and then surface that feature as, say, a REST endpoint. So you feed it parameters, it does its magic, sends back possibly a JSON payload or an XML payload. Did that answer your question? We okay on time, guys? Any other questions? No? Well, yeah, feel free to reach out. Yeah, I'll take another question. You could kind of, yeah, our founder developed, now this is getting, before Google there were engines like AltaVista and InfoSeek. He was, I think he was the architect on InfoSeek. And he decided, instead of indexing internet data, he says he wanted to provide search for corporate data. So but he knew that corporate data had to be transactional and secure and consistent. So that's why from the ground up, we've always had those enterprise features at that point it was an XML database, but then we just entered any kind of data, unstructured, semi-structured. And so integrated search technology and document management and semantic management as well. Yeah. Security is a very, very big feature of our system. We are in most of the government agencies that have the three-letter acronym, so CIA, HHS, Homeland Security. We have a certification called Common Criteria Certification. Whenever you sell to a government, they have certain security requirements. I think we're the only NoSQL database that has that. So in terms of features, so that's kind of like a reference cell or a certification bragging thing that I'm telling you. But in terms of the features, it's role-based access control, element level security. We could go down to the cell level and restrict access based on role. We also have encryption at rest. So this is to prevent bad actors within your organization from actually seeing the data. We have our own key management system, or we can integrate with key management systems like at Amazon or some of the other popular ones. And then data redaction. So when you might have the information in the database, you have to deliver it to people, whether they're analysts or operational applications. And some people, you might want them to know that there is a social security number, but you want to mask out everything but the last 4 digits, or just scramble the telephone number. Out-of-the-box redaction capabilities. So does that answer your question about security? And yeah, very high database. Oh, doing okay?
Yeah.
All right.
Thank you, Michael.
Thank
Thanks
you.
for taking time away from the beach and coming.
Yeah, back to the beach.